All right, this is Geometry B, Unit 2, Lesson 6. We're examining trapezoids and kites. Trapezoid always reminded me of, sci-fi movies. A zoid is an alien from the planet Krypton or whatever, and we've got to trap these zoids. So the trapezoid is the shape that traps zoids. Now trapezoid actually doesn't have an A in it, well, it has one A, but it's trapezoid. Trapezoid. And here's the definition. It is a quadrilateral, right? So it has four sides, and it has exactly one pair of parallels. Exactly one pair. It has only one pair, not two pairs. So a lot of people get confused on this item. Is a parallelogram also a trapezoid? It would make sense if it were, if all it was required was that it have at least one pair of parallel sides. But a quadrilateral with exactly one pair of parallels is a trapezoid. So one pair of parallels, two sets of parallels disqualifies it. It is not a trapezoid. So this is a trapezoid. I have one set of parallels, and the other two sides are not parallel. Trapezoid. Now, you can imagine, that's the definition, exactly one pair of parallels. But there are some properties that are also true about trapezoids, things that are true about trapezoids, properties. And one of the things we learned is when you have a parallel, set of parallels crossed by a transversal, that same side interior angles are supplementary. Now in a trapezoid we call these consecutive angles. So angle 1, measure of angle 1, plus the measure of angle 2 equals 180, because same side interior angles are supplementary when parallels are crossed by a transversal. Okay? We call these consecutive angles, consecutive interior. And the word is they are supplementary. They add to 180. So for example, if I were to tell you the measure of angle 1 is 88 degrees, then the measure of angle 2 is going to be 92 degrees because they have to add to 180, right? 180 minus 88 is 92. Okay, so that's one kind of question you might be asked about consecutive interior angles in a trapezoid. All right. There's a special kind of trapezoid that we're going to deal with as well, and that's an isosceles trapezoid. You've dealt with isosceles triangles. Now we have isosceles trapezoids. So let's define that. First of all, it's a trapezoid. So it has exactly one pair of parallel sides. Okay? But isosceles means the non-parallel sides are congruent. You may recall in an isosceles triangle, two of the sides are the same. Well, in an isosceles trapezoid, the two non-parallel sides are the same. They are the same. Okay, let's go ahead and draw it here. So let's set it up here, right here. Right, and here we go. And let's go down here and draw a couple out here. Okay. And this is an isosceles trapezoid because the non-parallel sides are congruent. They're the same length. Okay. And we're going to say it's a trapezoid, so these two sides are parallel. It's an isosceles trapezoid, so these two sides are congruent. Okay. And there are some things that are true, some other properties that are true about an isosceles trapezoid. In an isosceles triangle, back in last semester, you would have learned that the base angles are congruent in an isosceles triangle. Well, that's actually true here as well. But we have two pairs of base angles. So we can say that this angle here is congruent to this angle here. These are base angles. So, but there's also another pair of base angles that are congruent as well. So these two base angles are congruent as well. Okay, we have two bases, base 1 and base 2, in an isosceles trapezoid or in a trapezoid. Okay, and the same rule, since it's a trapezoid, applies. So let's say angle 1 here is 70 degrees, right? Then that means this angle over here is also 70 degrees because base angles are the same. Consecutive interior angles are supplementary, so they add to 180. 180 minus 70 is 110. So these two angles are 110. So if I tell you I have an isosceles trapezoid and I tell you just one of the angles, you can tell me all of the other angles, right? And as you can imagine, this has the possibility of writing and solving equations, all right? And you're going to get some of those here. So for example, let's say this was x plus 7, and this is 2x minus 5. In an isosceles trapezoid, the legs are the same. So we can write the equation x plus 7 equals 2x minus 5. And we can find an x value that makes that true. Okay. Same thing can be done with angles, summing up to 180, or angles that are congruent or equal to each other. Okay, that's a isosceles trapezoid. And there's one more property of an isosceles trapezoid that's worth mentioning too. And that is the diagonals of an isosceles trapezoid are congruent. Now you might be thinking, wait a minute, that's true, that's the property of a rectangle. Okay, but a rectangle is also a parallelogram. Okay, a parallelogram with congruent diagonals is a rectangle. But a quadrilateral with congruent diagonals is not necessarily, because it might not be a parallelogram at all. It might be an isosceles trapezoid. So AC is congruent to BD. That is, the diagonals are congruent in an isosceles trapezoid. All right, let's get on to our kite. Now, I don't know, one of my favorite memories of my dad when I was a little kid was for kindergarten, we had a kite day at school. And so Dad and I got out, we used the wrapping paper, like wrapping paper for birthday gifts and stuff. And took a couple of sticks. And I learned very quickly, very early, that you take one horizontal stick, right, one horizontal piece, and you find the exact middle of it, right? You find the exact middle of it, and you then affix a vertical piece, a vertical stick, tie a vertical stick to it. But that vertical stick does not have to be split down the middle. In fact, it typically is longer on bottom than it is on top. So we might do something like this, right? And we make a kite like so, okay? And so all of these things are true here about a kite. It's got diagonals that make a right angle. Did you notice that? That was true of a rhombus, but in a kite, it's also true. Okay, it's true in a rhombus, but in a kite, it's also true. And also the diagonals, we call the vertical axis, the major axis. The vertical axis divides the angles in half, and the vertical axis also divides the horizontal axis in half as well. But the definition of a kite is it's a quadrilateral, so it's got 4 sides, with 2 pairs, or 2 unique pairs. Unique, that means the pairs have to be different. 2 unique pairs of congruent angles. And someone's calling, but I'm going to have to return their call here in a minute. 2 unique pairs of congruent sides. Okay? 2 unique pairs of congruent sides. That is to distinguish it from a kite, or from a rhombus. In a rhombus, all 4 sides are the same. Okay? 2 unique pairs of congruent sides, and adjacent congruent sides. So the sides have to be next to each other. Next to each other. Okay? So here in this kite, the top two sides are the same, and the bottom two sides are the same, but the tops are not the same as the bottoms. That's the definition of a kite. A quadrilateral with two unique pairs of adjacent congruent sides. Okay? Adjacent congruent sides. All right. That said, here, there are some properties that are also true. Properties that, and we've kind of hinted at them already. Okay, the diagonals are perpendicular. They form a right angle. Okay, the minor axis is split in two. Minor axis is cut in half. Okay, that is that the left hand arm is equal to the right hand arm. 3 tick marks to distinguish it from the other sides. Okay, and the vertical angles, the angles that are vertical that are on the vertical axis angles, are bisected. So this angle is bisected, and this angle is bisected. Okay, so those are all true. So if I told you some of the angles, you might be able to tell me some of the other angles. So like if I told you this was 30 degrees, and we know this is 90, so this it must be 60, so that 90, 60, and 30 make 180, right? So you can tell me some things about the angles as well. Right? That's a kite. So we've talked about a trapezoid, an isosceles trapezoid, and a kite. And their definitions and properties are what you're going to learn this unit.